before leaving yesterday, you asked me to show how to install Anaconda, and it's a fairly simple process. Maybe I can show it on my screen once again to see how that works. Let me share my screen. Okay. So the process is really simple. You can go to Google, and within your Google, you can search for Anaconda installation or Anaconda install, which gives you the links, or it shows you the documentation on how do we install it. I will directly go to individual edition Anaconda. That takes me to the Anaconda website. And here you can click on download. Okay. Once you click on download, it takes you to this screen called as Anaconda installers. Now, depending whether you are installing for Windows, Mac or Linux, you can choose for your system. Okay. So my system is Mac OS 64-bit. So I can click on this. And what it will do is it will help me to download this file. So I'll keep it for now within the downloads folder itself. And click on save. It will take some time to download. Okay, so here it's taking around a minute. Let me finish this. So the procedure is exactly same for Windows also. When you click on download, it will download the Windows installation file for Anaconda on your system. Okay. Okay. So once the download is complete, you can click on this. Okay. So even on your Windows system, it will show it's like this, telling us this package will run. Press continue. Can just click. So we are doing the basic installation of Anaconda. We are not doing anything advanced. So whatever comes, you can just keep on clicking continue. Okay, continue or next. Just agree to every term that they give you. Install. Okay. 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 In my case, it is showing an installation failure because I already have Anaconda installed on my system. Okay. For you, when you do it a normal way, you can just keep on clicking continue, it will install. Okay. Now, if you're more interested, what you can easily do is go to YouTube, check for installing Anaconda, and you will get tens of different videos that will show you how to install Anaconda. Okay. So I'll close this for now. Now, once your Anaconda is installed, you can go to your Windows directory wherever your file is installed, and there should be a file called as Anaconda Navigator. Okay. You can open Anaconda Navigator, and what that will open is, you see this green type of GUI will open up, and it will load. Okay. Once it loads, it will give you this screen. Within this screen, since we are working on Jupyter notebooks, you can see there is something called a Jupyter notebook here. You can click on launch. Okay. And launching Jupyter notebook will take you to a browser window like this. And it will simply launch Jupyter notebook. Now, to create a new notebook, you come to the top left side, there is new here. Click on new, and normally here you should see Python 3. In my case, it shows these additional options because I have configured it for my system. Okay, so you can just click on any one. So here you should see Python 3. I'll just go to data analytics coaching. It should open a new notebook like this. Okay, once a new notebook is open, you can then follow whatever I'm teaching in the slides. You can follow it here. So this is one way of using Python on your system. Okay, if you get stuck, please check on YouTube. there are multiple videos that will explain how to install. One of the comments in the chat was saying, once you have this installed, how do you install Python? Okay, so how do you install Pandas? Now again, Pandas is something that we will see later as packages, but as a quick instruction, you can install it using two methods. In your command prompt or in your terminal, you can write the command like this: pip install Pandas. Now, if I want to do it in the Jupyter Notebook, I can put an exclamation mark in front of this, telling to Jupyter Notebook that this is not a Python command. In fact, I want this command to run on my terminal. So when you write this command and you press on run, it will install Pandas on your system. In my case, it says requirement already satisfied. That is, I already have Pandas installed on my system, so it is not installing it. Remember, to do this command, you need to be connected to the internet. Okay, if you're connected to the internet, your computer will connect to the internet. It will download the relevant files of Pandas on your system. It will extract it and install it on your Python system. Okay. So that is one way of using Jupyter Notebook on your system. There is another way that we discussed in the class earlier. What we discussed was something called as Google Colab. Okay, so you go to Google and you write Google Colab, you press enter. Okay, let me first do one more setting. Okay, you go to Google Colab, click on the first link here. Now, I hope most of us would already have a Google account. If you already have a Google account, you can simply log in. So in my system, I'm already logged in. Otherwise, it will give you a login prompt. You log in through your system, click on new notebook. Now, all the systems that we followed, all the programs that we would do normally in your Jupyter Notebook like this, you can do the same in a Google Colab notebook. Okay, all the commands that we saw, let's say A is equal to 5, B is equal to 3, and C is equal to A plus B. You can write it in your Google Colab. Okay. The advantage of this method is even if you have a system which is having low configuration, you can still do a lot of things on this cloud network. Okay, Google Colab, it is not working on your system. It is working on the cloud, but you're still able to run advanced programs within Google Colab. Okay. So can we do that process in mobile? I have never tried it in mobile, but I think it should be possible to run in mobile. You can try running Google Colab on mobile. You cannot do Anaconda installation in mobile. Okay, but you can, I'm guessing you can run Google Colab on your mobile. Okay, but again, it will be a long process. You will find it difficult to write programs on your mobile. So I would suggest you work on a laptop or you work on a system. Okay. So this was just an introduction before starting the content again. I will stop sharing from my laptop and again share from my iPad so that we can go directly to where we stopped yesterday. Okay. Okay. So yesterday we finished our first set of topics, that is operator and control structures. And we saw different kinds of operators: arithmetic, logical, relational, Boolean, and so on. And after finishing those operators, we also looked at control structures. So there are three major control structures that we saw. We saw the if-else condition loops, we saw the for loop, we saw the while loop, we saw the for and while loop with nested options and with else options as well. Okay. In today's class, I want to go ahead and talk about data types in Python. Okay. So this will be the content that we'll be speaking today. That is, what are the different data types in Python? So we have Booleans. Booleans are basically true or false. And we have already seen some part of this when we were doing logical operators, when we saw that we have certain conditions. Depending on when the condition is true or false, the answer is a Boolean data type with true or false. So note, we have true and false with capital T and everything else is small, and false also as capital F and everything else is small. Then there are numbers in Python. We have already dealt with numbers. So we can have integers like 1, 2, 3, and so on. We can also have negative integers. Additionally, we can have floating point numbers. So floating are numbers that have a decimal point. Like you have a decimal point, and then after the point, you've got your fractional part that is represented as points here. So here 1.1, 1.2, 3.47, or whatever. These are the different floating point numbers that we can have. Within Python, we can also have fractions like 1 by 2, 2 by 3, and so on. Or we can even have complex numbers. So far, Booleans, numbers are very common data types that we have already seen. Let me go ahead and talk about strings, lists, tuples, sets, and dictionaries. Okay. So before going ahead, there is an additional definition that is very useful for us. It is called as immutable data types. So immutable data types, we have within Python, strings and tuples are immutable, okay? Which basically means that once we create them, we cannot change them. If you create a string or if you create a tuple, you cannot modify the string or you cannot modify the tuple. In fact, a string creates a new string. It does not update the same string, okay? So you can create a new string that way, but you cannot update the same value or same object. The same applies for tuples. So these two categories are called as immutable data types within Python. The other option are mutable data types. So we have lists, sets, dictionaries, and they are mutable. And when I said they are mutable, it means that after they are created, we can add, we can remove elements from them. We can even modify elements from them. Okay. So immutable data types and mutable data types. Let's look at string. Strings are amongst the most popular data types in Python. So generally, we use a lot of strings within our Python programs. Even for data analysis, you would see that a lot of our features may be categorical. And in general, most categorical features are strings. Okay? We can create them simply by enclosing characters in quotes. So here is an example. I'm creating a variable called as var1. And this variable var1 will have a string value. So how do I create it? I say var1 is equal to, I put a single quote here, a single quote, I put whatever text I want to type within single quotes, and that is how I can create a string. So this string var1 has the value hello world. So when I print var1, or when I just write var1 as the last line of my cell and I execute this cell, it shows me the contents of this var1, which is hello world. Now within Python, you can have single quotes or double quotes, and they both are similar. They both are the same. Okay. So we have hello world here written in single quotes, and we have that is in variable 1. Similarly, we have a variable 2, which has Python programming. Now here also is a string, and we have enclosed that within double quotes. Okay. And you look at var2, when you print var2, Python says that, okay, single quotes or double quotes, it makes no difference to Python, and still it works the same. Okay. Now creating strings are as simple as assigning a value to a variable, as we have seen in both these cases. Okay, we just take a variable, assign its value, and that's it. We have created a string. Okay, so some students are saying that my voice is not audible. Can others, like, can someone confirm, is that the case with everyone, or are you able to hear my voice? Okay, so my voice is clear. So people who are struggling, probably because your internet connection is breaking down. That's the reason the voice is breaking as well. Okay, let me go ahead. Once we have created a string, we can access the elements of the string in different ways. Okay, so Python does not support a character type. So if you must have studied programming languages like C or Java or something else, you would know that a character is a different data type and a string is a different data type. Whereas that is not the case with Python. For Python, character type does not exist. We only have strings, and characters are just strings of length 1. Okay, they are treated as strings of length 1, thus also considered as a substring. Now, to access each character, we can use square brackets along with the index. Okay, so let's say here we have the variable 1, var1, and we know from the last slide that in var1 we had kept the string hello world. Now, if we want to access elements inside hello world, we can write a square bracket, open and close square brackets, and put an index number. So here, Python starts indexing with 0. So when you put var1 and within square brackets you put 0, you are able to access the first character here, which is capital H. Okay. Similarly, you can put the index 1, and this is index 0, index 1 is small e. That is what we get here. We saw the variable 2, which was having the string Python programming. And if I put the index 5 here, I can get here. So this is 0, 1, 2, 3, 4, and 5. Okay. So we get a small n here. Okay. So that is how we can access the individual elements of a string. So just for curiosity to see if you have got this concept, if I put var1 of maybe 4, can you tell me what will be the answer to this? And similarly, if I put var2 of maybe 3, what will be the answer to this? So what is the answer to the first question? Okay, so it should be 0, 1, 2, 3, 4. 4 is O. Okay, so many people have answered O correctly. Okay, very good. What about the second one? Okay, excellent. Many people have answered rightly. This will be H. Okay, you see it is 0, 1, 2, 3. So 3 is having the index H. Excellent. Let's go ahead. So within Python, interestingly, we can access the elements in the forward direction by writing 0, 1, 2, 3. We can also access elements in the reverse direction by writing negative indexing. Okay, so let's consider the string hello world. This string is having 12 characters starting from 0 till 11. Okay, so we already saw how to access it in the positive direction. To access it in the negative direction, when you write hello, when you write the index -1, you get the last value. -2, second last value. -3, third last value, and so on. So when I take var1 and I write the index -1, then I can get the text as exclamation mark. Similarly, when we write var1 of -5, we can get the axis O. Okay. So another question, if I want to access this L, can you tell me what is the index I can use in the positive direction and the negative direction? Two and -10. Excellent. It's the correct answer. So the same character can be accessed forwards or reverse by using the forward index, positive index, or the negative reverse index. Okay. Let's go ahead. Now, what happens when you try to access something that is outside the range? Okay, so let's say var1, we saw it had 12 characters starting from 0 to 11. When we try to access something like 100, it gives us an error, an index error. It tells us the string index is out of range. Similarly, in the negative direction, when we put -200, it again gives us an index error saying that the string index is out of range. So very simple, when you try to access an element that does not exist or that is outside the range of the variable, Python will throw an error, in this case an index error. Okay. Now within Python, it is very easy to traverse through a for loop, okay, with strings. So in fact, when we were doing for loops, we saw an example of this, where we had the string, something like this. We had the program for letter in Python. Okay, and then we saw that this variable letter could access the different elements of the string Python. Now we had directly passed the string here. In our case, what we are doing is we are taking the string into a variable var1, and then we are writing this in Python. So it says for I in var1. So what will happen is, it tells Python we can tell Python that for this variable var1, I want I to start from the first character, so the first character capital H, till the last character exclamation. Okay, so you can simply write for I in var1 print I, and that will print each of the different characters within the variable var1 on a single on different lines. Okay, so you get hello space world and then an exclamation and the loop ends. Similarly, we can also do something like this. What I'm doing here is I'm writing a for loop that will traverse through this variable 1, and whenever the value of I, that is whenever any of the character is equal to L, only those values we will print. Okay. So you see the string hello world has 3 L's, 1, 2, and 3, and only those 3 elements are getting printed. So we can easily traverse our strings using a for loop. Okay. Additionally, we can also grab slices from a string. Okay. So slices are trying to get a substring or trying to get a sequence of strings from the main string. Okay. So this works very similar to the range function. Remember when we were talking about for loop, in the last class, I discussed also the range function, which takes 3 inputs: start, stop, and step. And using those 3 inputs, we could create range of different numbers. Okay. Similarly, while we are trying to grab slice from a string, we can use these 3. Okay. The syntax is this way: you write the name of the variable. So this is the string. Within square brackets, you can write 3 numbers: start, end, and step, and you separate them using these colons. Okay. So to give you an example, when we write something like here, when you write var1 and within square brackets you write 0:2, the 0 is basically the start element. This 2 is the end element. When we don't write the value of step, then the default value of step is always equal to 1. Okay. So basically what this says is start from 0, stop at 2. So like in the range, we stop at 1 less than the value. Okay. So 2 means basically we'll stop at 1. Okay. And which steps of 1. So if I write the indexes here, let me write it. So this will be index 0, index 1, index 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So when we write a command like this, var1 0 to 2, we are saying start at 0, go till 1. So extract this part of the string. That is what we see here. When we extract this part, we get HE. From hello world, we are able to extract the first 2 characters HE. Similarly, let's look at this example where we are going start from 3, end at 6. So if we start from 3, so this will start at index 3, end at 6, it means it will stop at 5, right? 1 less than 6. So we get this string L, O, and a space. In the next example, we are saying start at 3, end at 9 with steps of 2. Okay. So this would translate to something like this. We'll say, give me the indexes 3, 5, 7. We will not go for 9 because 9 is the end point here. Okay. So we are going for the index 3, 5, and 7, which basically says capture this L, this space, and this O. Okay. So L space and O. That is what we get as an answer. L space and O. Okay. So let me ask you a question. If I want to extract the word world, okay, if I want to extract world starting from capital W till small d, what would I have to type between this? Okay, between the square brackets, what will I have to type so that I'm able to extract world? Okay, 6 to 11, that is the right answer. Okay, 6 to 11 will help me to extract word. Why? Because if I put 11, my code will actually stop at 10. So I will be able to extract word. Okay, excellent, right answer. And if I have to extract, okay, let's say I have to extract E, L, space, W, O, L, and exclamation mark. What will I have to do? So I'm extracting all the odd values, okay? So var1, and within this graph, what will I have to type? So someone has written 1 to 11 with gaps of 2, okay? 2 to 11 with gaps of 2. No, so far we don't have the right answer. Okay, okay. So let me tell you. So we start at 1, that is for sure. But you see, I also want this exclamation mark. And I know within Python, if I want 11, I have to go till 12, right? So I have to write 1, 12, and 2. And that will help me extract the answer. Okay, so in the end, some of you guys got it right, which is excellent. Okay, so writing this code will help me extract E, L, spacebar, O, L, and exclamation. So hopefully, maybe once we are done with this and we go to our notepads, we'll be able to see how to do this well. Okay, but I hope you have understood how to grab a slice from a string. Okay, let me go ahead. What happens when we leave certain things as blank? Okay, so the default values are this. When you leave the start block, when you don't write start, the default value of start is 0. When you don't write end, the default value of end is the last character. Okay, and when you don't write step, the default value is 1. Okay, so let's look at here. When we look at this example, where var1 has the string hello world, and when we write, we have not put anything for start, we have kept it blank. So blank colon 2 will basically translate to 0 colon 2, which is basically able to extract HE for us. Okay. Yes, Raghu, you're right. This will work. Okay, 1 colon 2 will work. For the last example, that will work out right. Since I had not discussed leaving the variables blank, I did not show that as an answer. Let me go ahead. This time probably we'll get it. Okay. When we write var1 colon 6, this translates to 0 colon 6, which says start from 0 and go till the first 6 elements, right? So this is H, E, L, so 0, 1, 2, 3, 4, and 5. So along with the space, hello with the space is what we'll get with this command. Okay. What happens here? So here we say start is missing. We have an end and we have a step. So this will translate to 0 colon 6 colon 2, which translates to 0, 2, 4. Okay, which is 0, 2, and 4, which is H, L, and O. That is what we are able to extract here. Okay. Now that happens when we leave the start part. When we leave the end part, then we reach the end of the string. So in this case, when you write 5 and colon, you say start from the 5th letter. That is 0, 1, 2, 3, 4, 5. Start from the 5th letter till the end. Okay, that takes space till the exclamation that is the last of the string. Okay. Now, interestingly, when we don't write the start, when you don't write the end, it takes from start till the end value. Okay, so starting from the first character to the last character, you get the entire string by writing this command. Okay. Again, an interesting application. When you don't write start, when you don't write end, and you take steps of -1, you can actually reverse your string. Okay, so steps of -1, no start, no end, says go to this character, last one, print it then first, take the next D, next L, R, and so on. So we can reverse the string by writing this kind of command. That is the entire string with steps of -1. Okay, so I hope this is clear. Let me go ahead. So that was our first data type, or probably our third data type, since we have already seen booleans and numbers and strings. Let us go to more advanced data types like lists. Okay. So lists is what? So lists is a data structure that holds an ordered collection. So what I mean by an ordered collection, it means the elements of the list will have numbers, indexes 0, 1, 2, 3, and we are able to access them using those indexes. That is what I mean by ordered collection. A list is a data structure that holds an ordered collection of items. You can store a sequence of items in a list. Okay, so you can store a sequence of items in a list. The list of items should be enclosed in square brackets. So just as we saw, we can access the elements of a string using a square brackets. Now, to create a list, we can use square brackets. Okay, so you'll write something like this. So let's say you have a list L. You can start with a square bracket, end with a square bracket. Okay. So anything that you write within square brackets will go into this list. So that Python understands that you are specifying a list. Once you have created a list, you can add, remove, or search items from the list. Okay, so lists are mutable data types. Once you have created them, you can modify them by adding values, adding new values, by taking an existing value and removing it out, or by modifying these values. Okay, either one of these works out with lists. Since we can add, remove items, we say that list is a mutable data type. This can be altered. Okay, so let us look at some examples. So here we see that to create a list, we have to enclose them within square brackets. And also we can separate the different values by using a comma. So here we're defining a list X. How do I know that X is a list? By looking at the square bracket in the front and the square bracket in the end. That tells me that X is a list. It is having 3 elements, 1, 2, and 3. All 3 are integers, and I separate them using commas. When you write X here as the last line of your cell and execute this cell, we can see what is the value in this variable X. It's a list with 3 elements. Similarly, I can create a list Y, and here you see we are creating an element. We are creating Y with all floats. So all of these are floating point numbers because they have a dot, and then they have I think what's the right term? The decimal and mantissa. I think that is what floating point numbers are called. I have forgotten. This has been long back. Anyways, we put a dot and then numbers. So these are floating point numbers. You can. That's what this list contains. Again, same procedure. Within square brackets, you put the elements, separate them with commas, and that is what you've got here as variable Y, which is the list. Okay. We can also have a list of characters. So within Python, we don't have characters. These are in fact strings of length 1. So you can have Z with strings of length 1, and that is allowed. And finally, the last case where you see that we can have multiple data types within list. You can have a list L, which can have multiple data types. So this one is an integer. We have a floating point number. We have a Boolean value. We have a string, an integer, string, a Boolean value. And all of this is allowed within Python. Okay. So just to contrast, if some of you have worked on C, in C, the similar concept of list is called as arrays. The only difference is arrays can be of a single data type. You can have an integer array, floating point array, character array. Okay, but whereas within Python, we can have lists which can have different data types all in the same list. Okay. Lists also allow duplicate values. Okay, so let's see this example here. X, I can have 10, 10, 25, 25 repeated multiple times, and that is allowed within Python. Okay, you can have elements with different lists. So now this is important because we have one data type called as sets, which we'll come across next. And sets does not have the capacity of having multiple data or having duplicates. Okay, whereas lists, there is no problem. I can have duplicate elements within the same list. Let's go ahead. Using list. So once we have list, similar to accessing elements of a string, we can access elements of the list by using square brackets again. So here we have defined a list X, which has these values 10, 25, 12, 38, 24. And if I want to access the first element, I can do it by accessing the index 0. So I write the name of the list. Within square brackets, I put the index. So I put 0, I'm able to access 10. Okay. If I put 3, so that is 0, 1, 2, 3, I'm able to access the element 38. Okay. Can you tell me what index should I put to be able to access the number 25? 1. Excellent. So you're getting this right. Okay. So we can access elements of a list similar to how we use strings. Okay. Let's go ahead. When we try to access an element that is greater than the list. Okay. So here we see there is the index goes from 0, 1, 2, 3, 4. So when we try to access something like X of 5, we get an index error saying that the list index is out of range. Why? Because X does not have an index 5. Similar to strings, we can also access in reverse. So if I want to access the last element, I can do X of -1, that is X and within square brackets -1, you'll be able to access the last index. Okay, so you are able to access positive indexes, negative indexes as well, even with lists. Okay. Now to create an empty list, what we can do is, there are 2 ways of creating an empty list. The first is I write the name of the variable, and I simply put open and close square brackets, and I leave it empty. I don't put any elements. In that case, we can create an empty list. So you can write A, and we can see we have created an empty list. Similar to that, we can create an empty list by using the list function. So the list function is an inbuilt Python function So you don't have to import any packages for this. You can just write b, or that is the name of the variable, is equal to list and open close parentheses. Okay. So one hint here, you can know that something is a function by seeing that you have the name and without any spaces, if it is followed by open and closed parentheses, then this becomes a function. Okay. That is a quick way of identifying if something is a function or not. Like here, list is a function. Okay. So let me ask you a question. When I write for I in range 5 and I say print I, can you tell me, is for a function? You can answer as yes or no. Is for a function? Okay, some people are saying yes, some are saying no, some are saying S. I'm guessing S stands for yes. Okay, so no, for is not a function. Okay, as I just said, the hint is anything that follows with an open and closed brackets just after the name. So if I had written for this way, probably you could have said that it's a function. So as someone has mentioned it rightly, for is a keyword in Python. Okay, it is not a function. Is range a function? Yes, excellent, right? Range is a function. Why? Because I can see that just after range, I have an open parenthesis, I have a closed parenthesis, and 5 is an input to the function. Okay, so range is a function. Is print a function? Yes, excellent. Okay, so you've got my hint. So list here is a function, and to create an empty list, we can write b is equal to list, open close parentheses, and that creates an empty list like this. Okay. We can also update the values in a list. Okay, so let's see here. Here we are creating a list X, which has these values 10, 25, 10, 38, 25. If I access X of 1, I can see that I can access this index 1 element. Okay, index 0, index 1 element is 25. I can also modify this element. I can write X of 1 is equal to 5. And what this will do is we'll take this value 5 and put it in the variable X. Okay. So in this list X, it will update the index 1 element. Earlier it was 25. Now when I see it has become 5. When you print X again, we can see that its value is updated to 5. Okay. That's a very simple way where we can update or we can change the value of a list. So this is called as mutability. Okay. Lists, as I said earlier, are mutable. That is, we can change the value of a list. Okay. Okay. So let us look at this example. It's a very interesting example and useful example as well. Okay. So here we have a list called as A, which has 3 elements, 2, 4, and 6. Now I'm creating another variable C, which I'm saying is list of A. So what it creates is it creates a new list, and this new list will take all the elements of the list A. So now when I print A and when I print C, I can see that both of them have same values. Okay. So list A has the values 2, 4, and 6. List C has the values 2, 4, and 6. Now what we do is we take the second list C and we update its index 0 element to 10. So index 0 element was earlier 2. Now we have updated to 10. Now when I print A and C, I can see that A remains the same. A remains 2, 4, and 6. And C changes to 10, 4, and 6. Okay. So this is one example. Just remember this example. I will ask the question after we see the second part. Okay. Let's look at the second part. In the second part, we have again the list A, which is having 2, 4, and 6. We make a copy of A. So we take B is equal to A. Okay. When you write B is equal to A, B becomes a copy of A. Okay. So when I print A and B, I can see A is 2, 4, 6, B is 2, 4, 6. Now I want to update something. I take B and index 1 element, that is this 4 element, replace with 12. So I say update this value from 4 to 12. Now when I print A and B, I can see that I have just updated the value of B. I've updated this to 12, but A has also updated. Okay, the value of A has also updated to 12 and 6. So this here is the concept called as deep copy or shallow copy. Okay, so let me highlight this. Deep copy and shallow copy. And what these are is this kind of copy. So here C is a copy of A. This is called as a deep copy. Okay. In deep copy, when I update one element of one of the copy, the other element does not get changed. Okay. Like we changed this 2 to 10, C got updated, but A did not get updated. This is called as a deep copy. When I do a shallow copy is this. When I just say B is equal to A, I write a shallow copy. I update one of the elements. So I update this 4 to 12. I see that A also got updated. It's called as a shallow copy. Okay. So just as a note, maybe what is happening in the background, in deep copy, these values, this list A and C, they have separate memory locations. Okay. So when you update one thing, the other does not get updated. Whereas here in a shallow copy, when you update one thing, the other gets updated. It means they are pointing to the same. They are pointing to the same location. Okay, they have the same memory location. That is what they are pointing to. Okay, so if we update A in deep copy, what happens? Okay, that is what I'm explaining. Okay, so when updating A in a deep copy, C will not get changed. Okay, C will not get changed. They are separate things. Whereas here in a shallow copy, when you update A, B will also get updated. When you update B, corresponding update will be made in A as well. Okay. Now this concept is important because we will come across this concept even when we work on data science projects. That is when we are working on data, especially when we're using Pandas. Okay. So keep this in mind. When we revisit this same concept within Pandas, I will have something more to talk upon it. Okay. Okay. Let us go ahead. Now we have list comparison and slicing. Okay. So similarly, how we were able to extract slices with similar to how we were able to extract slices within strings, we are also able to extract slices within lists. So let me read some people asking some questions. So in shallow copy, does the location of a shift of A shift to B? No, in fact, they have the same location. In a shallow copy, they have the same location. So you first created A will have a memory location, and the same memory location will be copied to B as well. Okay. And in deep copy, they have different memory locations. So maybe we are thinking this too much. You need not go deep inside this idea. You just need to know that this exists so that you can use them well. Okay. Maybe let me reiterate one more thing. The only reason we are studying Python here is so that we can use it on our data science projects. Okay, so that we can use it on our data science applications. Okay, we are not really interested to becoming experts at Python. So someone is asking, what is the use of an empty list? So an empty list is you want to initialize something as empty, and then you're doing some processes in which you're writing a loop of some sort where you will keep on adding items. Okay, that is what the use of an empty list is. You start with empty list and then you slowly keep on adding items to that empty list. So maybe once we come to some examples, it will make some more sense. Okay, let's look at here. Here I have two lists, A having the values 2, 4, and 6, B having the values 3, 2, and 5. I can access individual elements and compare if they're true or not. So here, if I say A of 1 is equal to B of 1, so we are saying if 2 is equal to 2, A of 1 is this element 4. Okay, so this is index 0, index 1. So index 1 is 4. Is 4 equal to 2? So it gives us false. No, that is not right. It gives us a false. Okay. Similarly, when we want to test if this 2 is equal to this 2, we write if A of 0 is equal to A of 1. And since this 2 is equal to this 2, we say, okay, true. This is right. Is A equal to B? That is, we are checking if A is equal to B. And this gives us false because not every element of A is equal to every element of B. If every element of A is equal to every element of B, then this would have returned to us a value of true. When we check something like this, is A less than B? Now this is basically a ridiculous thing to do, because what we are doing is we are comparing two lists, and these two lists are having different elements. You want to compare is one true or not. So even I would not be able to say if this is right or not. So what actually happens when we do a statement like this is Python compares the first element here and the first element here. Okay, so it says if the first element of 2 A is less than the first element of B, then it returns to us a true. But I would highly recommend not to use something like this. Someone is asking, sir, we can use empty list. Can allocating the memory, that memory allocation is one of the drawback. I don't really understand your comment. Let me go on ahead. Okay. So here, this is another example when I'm writing A as a list, and these are the elements in the list 0 to 10, and similar to strings, we are able to access the different elements by using slices. So here we start with the slice, start at 1, end at 4. So we see what we are able to extract. So start at 1 means this is index 0, index 1, index 2, index 3 is what we'll be able to extract. Because 4 means we'll stop one less. Okay, so we are able to extract the sub list 1, 2, 3. If you write :6, we are able to extract the first 6 elements starting from 0 to 5. If you write 3:, we are able to extract from index 3 till the last value, that is this 3 to 10. When we write something like this 2, 8, 2, we will be extracting the indexes 2, 4, and 6. Okay, that is what we get here exactly 2, 4, and 6. So just like strings, we can extract slices from a list. We have also seen how to compare lists and so on. Okay, let me go ahead. Additionally, see that list here is anything in Python that is even integers or data types. Python is highly object oriented. Okay, so most things of Python are implemented as classes. So when you do a help on list, you can see that it is a class object. Okay, so list is a class. Okay, so when you talk about classes, these classes have certain inbuilt methods that can be used, or they can also modify operators or the working of operators. So something is called as operator overloading. Okay, so let me take some examples that will make things clear. So let's say here we are having a list L1 which is having these elements 2, 3, 4, 5. We have a list L2 which has these elements 6, 7, 8, 9. And when we do something like this, list L1 plus L2, okay, list L1 plus L2, what is happening here? Okay, when we take list L1 plus L2 and store that into the list L3, what actually happens is, just one second, that we take all the elements and we join all the elements of L2 or concat all the elements of L2 here, and that is stored in the variable L3. Do you think this is very normal? What other thing could the additional operator do? Okay, what do you expect the additional operator could have done? So normally this is not how the additional operator works, right? So when I write something like this, when I write 5 plus 4, I don't get 5 comma 4. Okay, what I get is 9, right? So an additional operator actually numerically adds the values. Okay, but we see here something else is happening. I am not getting the addition of L1 plus L2. I'm not getting 2 plus 6 as, I'm not getting 8, 10, 12, and 14 as the answer. I'm getting a list, I'm getting the answer as a list, which is actually the concatenation of two lists. Okay, so here what has happened is this operator has been overloaded, or the operation of this operator has changed to do something called as concatenation. Okay, and this is not simple addition. So a data type can be a class. Yes, within Python, data types are actually classes, and these classes have different methods associated with them, and they have different operators overloaded as well. Okay, so if I want to do something like this, if I want to do 2, 3, 4, 5, and I want to take this list and I want to add the answers so that I get this answer, let me see if any of you knows the answer to this. If someone who has worked on Python before may know the answer, how can I add two lists item so that I get this answer rather than this answer? Okay, does anyone know the answer to this? If I add these two lists, so that I want an answer this. What could we do in Python? Okay, since you're not responding, okay, one is using a for loop. Of course, we can use a for loop, and for each index, we can numerically add the values. That is one answer. But in Python, there's a simpler way to do it. So maybe when we come across that, we will look how to do this in Python in a simple way. For now, okay. For now, no, that's not right. For now, we will look at how this is done. Okay. So this is simply adds two elements. When we multiply 3 with a list, okay, you would expect that each element of L1 would get multiplied by 3. That is 2 by 3, 2 times 3 should be 6, 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. But that is not what happens. What happens is basically this element L1 gets repeated 3 times. We have 2, 3, 4, 5, 2, 3, 4, 5, 2, 3, 4, 5. We get 3 copies of L1. That is what is happening here. Okay. When you take L1 multiplied by 3, we get 3 copies of L1. Instead of multiplying each element with 3, we get 3 copies of L1. Okay. Further, let us look at another function. This is called the len function, len function, which gives us the length of L1. So when you write len of L1, that is, we know L1, len is a function because open and close parentheses. We pass this list L1 to it. And when we do that, we get the answer 4 because there are 4 elements in L1. Okay. So people are asking, please explain again. So let me not confuse you. Let me say in simple, what happens when we add 2 lists? When we add 2 lists, we actually concatenate 2 lists. So L1, 2, 3, 4, 5, we concatenate that with 6, 7, 8, 9. Concatenate is a fancy word of saying basically join. Okay, so we join these 2 lists together so that we get L3. When we multiply a list, it duplicates, or in this case, since we're multiplying by 3, it triplicates the answers. So L1 gets repeated 3 times. And when we write len of L1, it gives us the length of the element 2, 3, 4, 5, so that we get the answer as 4. Okay. So now these are different functions that are available on the class called as list. There are ways where we can add elements into a list. Okay, so I just want to finish list for today so that we can end our topic. Let me increase my speed a little bit more. Okay, so when I take L1 as 2, 3, 4, 5, if I want to add an additional element 6, I can do L1 dot append 6. And what that does is it appends the value of 6 to the end of the list. So now this becomes 2, 3, 4, 5, and 6. Now to access, see, L1 is actually an object of the class list, and to access the methods inside of this object, I can use the dot operator. So L1 dot, the name of the function that is available within the class list, and then arguments that you can pass to it. So simple, L1 dot append will help us to add elements to the end of the list. Let's say we create another list called as L2, which has these elements 4, 5, and 6. So we can see L2 has another list 4, 5, and 6. When we do something like this, when we say L1 dot append L2, we are adding or we are appending this list L1 with L2, right? So what happens here is when we do this append, this 4, 5, 6 comes as one element. Okay, so L1 has length. So L1 has 1, 2, 3, 4, 5, 6 elements. The first 5 elements are numbers, and the 6th element is actually a list item. Okay, the 6th element is a list item. So that is what append does when you add a list. When you add a single number, it simply gets added as an integer, whereas when you add a list, it gets added as a list. If I want that it should not get added as a list, if I actually want that I want the individual elements to be appended to the list L1, I will not use the append command. I will use the extend command. Okay, and what extend command does is basically takes list L1 and extends that list with the elements of list L2. So here, this was L1 till this point. When you extend with L2, the 3 elements of L2, that is 4, 5, and 6, gets added as individual elements. Okay, that is how we work with the extend command. There is another command called as the insert command, and using the insert command, we can insert in any location. So you see, either we do append or extend, it will add elements to the end of the list. What to do when you want to add elements somewhere in between? Okay, so here we write insert 3 comma 7. So what it does, it goes to the location 3. This is index 0. So let me go here. Index 0, index 1, index 2, index 3. At this location, it inserts this value 7. So after 4, instead of 5, we have inserted the value of 7, and everything else gets pushed to the right. Okay, so we are inserting something between 4 and 5 by using this command, insert 3, comma 7. The first input tells where we want to insert. The second input tells what we want to insert. Okay, so in this case, we want to insert 7, that gets inserted here. Okay, so that's a simple method for inserting. Let's also see how would we delete elements. Okay, so if I look at L1, you see at index 2, what did we have? Let me go back. Index 0, index 1, index 2. So at index 2, we had the element 4. Okay. Now, when we want to delete things, when we write L1 delete, or short for delete, del space L1 2, then we have removed that fourth, we have removed the element at the second index. That is the item 4, we have removed it. Okay, that is how we delete this part. If I want to delete the entire list, I can simply write delete del L1. So the entire list gets deleted. So now when I write L1, it gives me a name error saying that L1 is not defined because we just deleted L1. Okay. To continue our example, let me again create L1. So now I'm creating a new variable L1 with the elements 1, 2, 3, 4, 5. And when we do L1.pop, okay, what it does, it removes the last element from the list. Okay, the last element here is 5. When we do L1.pop, it removes that last element and captures it into the variable that we are writing here. So we are writing x is equal to L1.pop. The last element 5 goes into the variable x. So when you see x has the value 5. But when you print L1, we see that L1 does not have the last element. The last element 5 is removed. Okay, that is how you would delete the last element from a list. If you want to remove a certain index location, you can pass an input within the pop element. Okay, so when you write pop without any inputs, the last element will be removed. But when you write pop with one input, so in this case we are writing pop 2, so it goes to index location 2, right? So 0, index 0, index 1, index 2. But index 2 we have the element 3. When you write L1.pop2, the element 3 gets popped into this variable x. Now when you print L1, we see that 3 is missing. Okay, why? Because we have popped this value. Okay. Like pop, we can remove elements also. Interesting thing, with remove element, you don't write the index value. You write the value that you want to remove. With pop, you give the index location that you want to remove. With remove, you can write the value that you want to remove. So this is the value of L1, 1, 2, and 4. When we write remove 2, it removes the element 2 from this list. So that now we have only 1 and 4. Okay. So what happens when you try to remove something that is not in the list? So in this list 1, 4, we don't have the element 5. So when we try to remove 5, it gives us a value error saying that list remove x is not in the list. This value x is not in the list. Okay. So let us stop at this point. We will continue tomorrow with the different methods within that you can use with list. Something like max, minimum, sum, count, and index. Okay. Okay, then let me stop sharing. Neerja ma'am, I'll be stopping for today. Is that okay?
Okay, sir.
Okay, we'll continue tomorrow.
Sir, one more thing.
Yeah, go on.
Sir, how to get material on Elon website? If possible, explain one, sir.
I am not sure. Is someone not updating this on elearn.org?
Yes, sir. Not updated.
Yeah, I don't know. I have to talk to my employer and see.
Okay, sir.
So I'll
He'll
talk to
update
him.
me, sir.
Yeah.
No, sir.
Okay, I'll talk to him, and if something comes up, maybe I'll talk tomorrow. Okay.
Okay, sir. Okay, sir.
Okay, then bye bye.
Okay, sir.